So, hello everyone. Now we're going to see the next question that goes by missing number. So, you'd be given n integers. So, you'd be given n integers in the range 0, comma n without any duplicates. Okay. So, we have to return the single number in the range that is missing from the numbers. Single number that is missing from the numbers. Right? And yeah, let's just see. So it has been given that if we could do it in 0, 1 extra space complexity, big O of 1 extra space complexity and big O of n runtime complexity. Let's just see what we can do. The first thing that comes to my mind is, the first thing that comes is sorting. Sort everything and then see with I. Is this, if I sort it, it would be 1, 2, 3. And then I can very well check I plus 1 and I, right? Are you getting what I want to say? If I can check it, if this is all sorted, and if my first element is 0, then I have to check it with I, okay? But if it is 1, I know 0 is missing for sure. Are you getting it? Because 0 has to be there always. It is 0, comma n. So after sorting, if my first is not 0, then I know 0 is missing. But if first is 0, let's say 0. Then I can check, is I equal to answer I? Okay, I is equal to answer I. But here I is 1. Is I equal to answer I? No. So this is my answer. Are you getting it? Sorting. Big O of n log n. Problematic, right? This is problematic. Second, what if I use hash map? Keep everything in and then check with I, is it present? Very great. Big O of n. Now you would say, wow, I found the answer. But no. Who will talk about the space complexity? Space complexity is big O of n, and this is the problem. Here your space complexity was big O of 1, so I did not say anything about space complexity. But here space complexity is the issue. Now third thing, I will go with maths approach. And then fourth, I will go with bit manipulation approach. Okay, now let's go with maths. Now it says what? 1, 2, and 3. So you have to have elements until 0, from 0 until n. So this is 0, comma 3. So 0 is missing. How do I know that? You can, if I find sum by the formula n into n plus 1 by 2. And then I find the sum of the given numbers. Now let's say we will take 0, comma 2. It is 2 numbers, right? So I find the sum. I say 2 into 3 by 2. Right, you say the sum is 3. Then I say find the sum of the given numbers. You say it's 2. Then I say what is the difference? You say 1. Then I say 1 is the answer. And if you say 1 is the missing one. Are you getting it? Let's do it with a bigger example. I have 0, I have 1, I have 3, I have 2, I have 5. Now it's still 5, right? 1, 2, 3, 4, 5. N is 5. So what is the sum? N into n plus 1 by 2. 15 is the sum. Now I say now I tell you to calculate the sum of these given numbers. You say 1, 0 plus 1 plus 3 plus 2 plus 5. 5, 7, 10, 11. Now I ask you to find the difference. You say 4. I say 4 is the answer. 4 is the missing number. Are you able to find it? So this takes the time complexity of big O of n and the space complexity of big O of 1. Time complexity of big O of n is, taken when you find the sum of numbers. While you're finding this sum is big O of 1 because you don't have to legit do anything. You just have to calculate it, right? And it's just a calculation. You don't have any dynamic n out there. Then you have your next approach that goes by bit manipulation. So now you remember I told you one thing, that if you XOR any number with 0, what you get is the number itself. And if you XOR two like numbers together, what you get? You get 0, right? And you already know A XOR B XOR C is equivalent to A XOR B XOR C, right? And also, you know, A XOR B is equivalent to XORing B XOR A. With all this in mind, if I tell you that, hey, you have the numbers from 0 to n, and if you XOR it, you know, there is one number missing. Let's say I've been given 1, 2, 3, 0, and 5, right? Now, if I XOR this with what? I XOR all this with zeros or ones or twos or threes or fours or 5. Okay, now just see. 1 XOR 1 will give me 0. Gone. 2 XOR 2 will give me 0. 3 XOR 3, 0. 5 XOR 5, 0. 0 XOR with 0, 0. 0 XOR with 4. 4 is the answer that I'm going to get. Sorry. Are you getting this? Does that make sense? Yes. Now we'll quickly move on to the coding part. First, I will just quickly write the code for the sum part. Right? Int. What is your that? Missing number. Int missing number vector int input. Right? Make sense? Now int answer. What is my answer? I don't know. So I'll just calculate the sum first. Sorry, in sum is, okay, first I need n. N is ip dot size. Then I need sum. Sum is n into n plus 1 by 2. Then for int I is 0, I less than ip dot size or I less than n, whatever goes, whatever you want, right? Right? And then you make here int sum 1 as 0. Sum 1 plus equal to ipi. Then what you have to return? You have to return sum minus sum 1. Does that make sense? And this loop tells you that this is going to be big O of n time complexity. Now let's just come to the bit manipulation code, okay? Int missing number, that's a vector, int ip. Sorry. Yeah. Then you go with int n is input dot size. Then you do what? You take int XOR as 0, right? Then you say for int I is 0, I less than n, I plus plus. Now you see what I have to do. I have to XOR it with I and with IPI. Okay, and I have to return XOR. Now you have to see what the issue is going to be. So what you have in was 12305. Okay. Now let's just see, because lest you won't understand why I have done a thing and why I will be doing a thing. I've not done that yet in code. Okay. So what I'm telling you to do is you do XOR. Okay. And now when you're doing XOR, what you do? You come here, then you do 0, XOR 1, right? Then you go in here, you do 1 XOR 2. Because this is 0, 1, 2, 3, 4. Then you come to 2 and you say 2 XOR 3. Then you come to 3 and you say 3 XOR 0. Then you come here and you say 4 XOR 5. Are you getting that? Great. Now if you see, I will never be XORing it with 5. Are you getting it? See, 1 1 gone, 2 2 gone, 3 3 gone, 0 XOR 0 gone. 4 and 5, two different numbers. Because this 5 I will never get in I. Are you getting it? And I cannot do I plus 1 because I want to XOR it with 0 because 0 can also be there. So what I'm going to do is I'm going to initialize it here with n. Do you get it now? Int XOR is n. I hope it makes sense. Lest if you go through the code once again, you will get to know what I want to say. You just keep in mind this example, right? And then if you see this big for loop, you'll tell me that C, time complexity is bigger of n. Space complexity is bigger of 1. If you still have any concerns, any doubts, if you want me to, go in and dig deeper into this first approach, second approach, just let me know the same in the comment section. I'll be more happy to, create it out or curate out a video for the same. And if there are any concerns in these two approaches, you can use any approach. Both give you the same time complexity, the same space complexity. So yeah, if you have any concerns, just let me know and I'll, be very happy to make sure you've understood the code well. Just make sure you're making use of the comment section should there be any doubts, right? With that, I shall take your leave. Bye-bye.